Alright, we're recording. Yeah, we're good to go. How is everyone today? I'm sensing it's a low energy kind of day.
Yeah, not too bad. I got tripped up on that ODP 411 from not initializing the variable and forgetting that the stack overwrites, even though you mentioned it.
Oh, yeah, yeah. Always good stuff. Let's talk about ODP 411 and take that apart, and then let's go on to 412. So let's look at 411. So 411 we were doing something like we did in the previous ODP, where we took a string and we tried to determine if it represented a valid integer. And valid integer means, you know, it can start with spaces, but then it's got to be an integer, and there can't be anything else except maybe spaces after the integer. So, you know, 2x is not a valid integer, 2.3 is not a valid integer, and so on. And so we wanted to look at this string that was being passed to a function, and if it's a valid integer, and it's 1, 2, or 3, return 1, 2, or 3. Any other case, return -1. Whether it's invalid or it's valid but it's out of range. So that was our basic setup. Go ahead and send me an attendance note. Let me know who's here, and let's look at an approach for this this ODP. So some of this is probably familiar from an earlier assignment. This idea of using an sscanf, taking the string we want to parse, parsing it with the %d, %s, and this is the whole trick. This funny thing we do where we say %d means look for an integer, but then let's also look for something after the integer. And for each thing that we try to match, we have to have a variable to store the matched thing into. And so the integer will go into I, and the extra stuff will go into temp. Are other people getting choppy video from my end?
Not video, but the audio goes a little bit robot sometimes.
Oh, okay. Interesting. So mixed bag. I'm uploading the previous video. Maybe I should leave those for after class. Let me know if it gets worse. Alright, so this scanf trick that we've seen before, I use a %d and a %s, throw the extra stuff into just a character array. I called it temp. We've been calling it extra in class usually. So what can we do after this sscanf? Well, the first thing we can do is check the return value from sscanf, right? And that tells us the result of parsing. It doesn't tell us the values that it found, but it tells us how many values it found. If it does not match anything in here, return will probably be 0. If it matches an integer, but not anything after that, return will be 1. If it matches an integer plus some extra stuff after that, return will be 2. And as a special case, if this string was empty, if there was no characters in here at all, return would be -1. So if you write those out and look at them, how do you know if you've got a good integer? Return has to be equal to exactly 1. If return is different from 1, there's a syntax error, and for this assignment we just return -1. And then if we get through this statement, that means return was equal to 1. I is an integer, and now we just check to see if it's in range. So if it's between 1 and 3, we'll return I, otherwise we'll return -1. And once again, there's lots of ways you can do this. There's lots of ways you can structure the logic. This if statement could be written, 5 or 6 different ways that'll all work the same, that'll all do the same thing in the end. But the first tricky part is, doing this sscanf to test the legality of your input, and then this is just logic, right? So make sure your integer is in range and return the integer, otherwise return -1. So ODP 412 will do something similar. Yeah, I just typed a VI command.
It looks nearly the same, except for you getting argc and argv passed in from main, right?
Yeah, so this is another similar problem of taking a string and parsing it, and checking to see if it has an integer, but with a few other details. So the biggest difference from 411b is that we're not just passing this thing a string, we're passing a pair of arguments. The first is an integer, the second is a char star star. And I've named these, for the sake of argument, argc and argv, which are what we usually name the arguments to a main program. Well, these are arguments that look like what you pass to main. So when you write a main program and you say, integer main parentheses, int argc, comma, char star star argv, right? Those are the kinds of things you should pass to this. And we don't actually need to understand yet what this char star star is all about, but we'll start talking about that at the end of class today. But really, all you need to know is that this first argument to the function you're writing, start, should look like the first argument when you run main. And the second argument should be like the second argument when you run main. So we'll put together a test program for this in a minute. But let's look at the behavior of the program first. So first thing you want to do is check argc. If it's not 2, just return -1. Okay, but you got to do this first. If you try to do this thing before you've done this thing, your code's not going to work. The first thing you got to do is check argc. And that's usually the first thing you do when you write a main program and you're processing arguments. So check argc. If it's anything other than 2, return -1. And you got to do this. If you say if argc equals 2, return -1. If argc equals 3, return -1. That's different, right? If argc is not 2, so exclamation mark equal 2, return -1. If you don't return, what do you know? Excuse me. You know your function was called with argc equal to 2, and there's 2 things in this array. In particular, we can use argv bracket 1. So now you treat this like a string, and you do your parsing. Do an sscanf %d %s to see if it's an integer. If it's not an integer, return -2, and you're done. If it isn't, yeah, go ahead.
Oh, actually, sorry, I'll wait till this is done. This doesn't have anything to do with 412.
Okay, cool. If it is an integer, check to see if it's positive. Positive means bigger than 0. 0 is not positive. 1 is positive. 2, 3, 4 are positive. So if it's not positive, if it's 0 or smaller, return a -3. Otherwise, if you've gotten through all of these checks, then go ahead and return whatever the integer value was of argv bracket 1. So you're going to do your sscanf on argv bracket 1, but only after you've checked to make sure argc is not equal to 2, or is equal to 2. If it's not equal to 2, return -1.
So can I ask you a question on the results?
Sure.
Using the variable result. So because we're using %lf first, is that why if there is a string first, you get result 0 because it doesn't see an integer, so it just gives us back a 0 integer?
Yeah. So let's draw this out.
Yeah, on that note, it's strange to me that we don't have anything separating the different formatters that we use to pull info.
Well, yeah. Let's talk about that
I'm
too.
just curious the behavior of the whole thing. I think I pretty much understand, but I want to make sure.
So we're playing with this kind of scanf statement. So this format string, right? It's kind of what you see in printf. If I did printf with a %d, %s, and I had a number and some extra stuff, it would print an integer followed immediately by whatever the string was, right? And I guess the idea is if the person runs a main program and they type an argument like, 12 space hello, we're going to know this happened because we're going to check argc first. And if they said main 12 hello, argc is going to be 3. Right there we can say you made an error. So we don't have to worry about the scanf picking up the case where there's a space between the integer and the string, right? What we do need to worry about is if they type something like 12 hello, because here argc is going to be equal to 2, and we're going to say, hey, you did one argument, good job. Let's look at it. And the pattern we're looking for is an integer followed by other stuff, right? So that's what the %d with the %s right next to it is indicating. But let's just look at this, forget about the main program, let's just look at this in terms of this one statement. And for different values of your string, let's see what num and extra are set equal to, and let's see what the result is. Alright, so if your string is, a 2, what does sscanf do? It starts at the beginning of the string and it looks for an integer. Well, it sees a digit 2 and it says, yeah, that could be part of an integer, cool. It checks the next character, it's the null terminator, it's the end of the string. But it did see an integer. It saw the number 2, so it's going to say, okay, hey, I saw %d, I'm going to save the integer value 2 in num. But it did not find anything after the integer to match the %s. So it's not going to change the value of extra. So extra is basically unknown. And then the return value it gives you tells you how many things it converted. It converted an integer, it did not convert a string. It converted one thing. So for that string, this is what would happen after we executed this statement. Num would be 2, extra is unknown, and result would be equal to 1. Now if you type 2x, it's going to match the 2 with a %d. That'll get saved in num as an integer. It'll find this x and say, oh, that matches a %s, which matches any string of characters. So extra will be set equal to x. And result will be equal to 1, 2, because it saved 2 values as a result of parsing. If your input is just x, it looks for a %d, an integer, and it finds an x. X is not part of an integer, it's not going to do any conversion. So num is unknown because it hasn't changed it. Extra is unknown because it hasn't changed it. And what does it set result equal to? Well, how many things did it convert and store? None. So that's going to be a 0.
See, that's what threw me off when I messaged you for help.
Mm-hmm.
Because I assumed, because we were looking for an integer and a string, that if you put, basically I had everything working except if I would put the string first, then everything kind of went wonky and it crashed my program. So
Oh, okay.
Like, what am I missing? Because it should still be 1,
Oh, okay.
That threw me off.
Right. Yeah, so sscanf gives up as soon as it doesn't find something that matches the pattern. It stops there. It doesn't look ahead.
If we were doing it the other way, we switched the formatting tools and switched the variables. So we would be looking for a string first, and then it would pick out and give us results properly that way.
If we did a string first, all of these would get absorbed by that %s. Because 2 is a valid string, that would match %s. Extra would be equal to 2. Num would not get saved, and result would be 1. %s will match basically anything.
Okay.
How would you search for a string and then followed by an int?
You can't really do that with a %s. Now, if there was a space in between them, you could do a %s space %d.
Would you have to put in like separate characters
but there'd have to be a separator. Yeah, because %s will pick up digits, characters, punctuation marks, all that kind of stuff.
So that's not really a good way to go with it then.
Yeah, and parsing a string with an integer after is fundamentally trickier because integers are strings, right? So we need to parse a string that doesn't contain an integer followed by an integer. And then just for extra kicks, if you pass an empty string here, it's not going to succeed in converting any of these, but it will actually give you a value of -1 to say, hey, I didn't find anything at all to parse. And the only one of these that we want to even consider the value of num for is this one, which is why we want to make sure that result is equal to 1 before we do anything else. So if result's not 1, we're gonna say error. Even though, you know, we got a 2 here that matched that 2, right? It's not a valid input string, and we know that because result was not equal to 1. So apologies if the video is choppy, but the recording should be solid because that's not network bound. So if there's parts of this that aren't coming through, you should be able to catch them from the video later. All right, so that's the whole sscanf business that we've been working with. So this is very similar, except the string that you're parsing is argv bracket 1, right? And we're not going to use that unless we first check argc and make sure it's equal to 2. The part that gets confusing about this assignment, though, is how do you test it, right? You're writing a function called start, and you know, you can link it with a test bed and assess it. But if you want to test it on your own first and run some test cases through it and see what it does, right? How do you call this function from your own main program? And we're not really ready to talk about how to construct a car star star array with your arguments in it, but we don't have to, right? If you write a main program and you just make the arguments argc, argv, we can take those arguments to main and just pass those directly to this function. So let's make a sample test program. So sample main program for ODP 412. I can make it void. And I'm just going to pass argc and argv to my function, which is called start. This is just not equal, so exclamation mark equal. Some languages you write it as a less than greater than sign.
Just for debugging reasons, you standard IO in this stage.
Oh, cool, thank you. All right, so really simple test program here, right? I'm just going to call my start function. I'm just going to pass it argc, argv from the main program. I'm going to save the return value and return value, and I'll just print out what the return value is. So this is my test bed, and I'm assuming that you've already written start.c, which does, you know, all of this stuff. So you've already written it, and now you want to test it. So you can write a main program like this. And compile it, link it with your start function. And now you can just run main. And if I don't give it any arguments, it says -1. If I give it more than one argument, it says -1. If I give it an argument that's not a valid integer, it gives me a -2. If I give it something that starts with an integer but is not a valid integer, it gives me -2. If I give it a valid integer but it's not positive, it gives me -3. But if I give it an argument that's a valid integer, there's exactly one argument on the command line and it's positive, then it just gives me back the value that I gave it. Cool. Alright, so you can use this while you're developing your start function as an easy way to pass arguments to it. And whatever I type after main, that will be what goes into argv bracket 1. And so when I'm doing these kinds of things like checking argv bracket 1, it'll be whatever I typed in after the name of my program. And if I put more than one thing on the command line or nothing on the command line, then when I check argc, I'll find that it's not equal to 2. And that should just return -1. Alright, so questions on that, questions on how to make a test program, or on what the start function is supposed to do.
Can you show me the command for the readme? For some reason I'm not able to find it.
The command for the what?
For the readme?
Oh.
I'm going to temp and then readme and it's not pulling up.
Like that.
Oh, just 412, okay. I was looking for OGP 412.
Okay.
Okay, thanks.
Yeah. And remember we have command line completion, so I could say /temp/re and just hit a tab and it will fill out as much as it can, readme-4. And if I hit a tab twice, it'll show me all the things that begin with /temp/readme-4. And that can be a way to find things sometimes.
Oh, cool.
This isn't a very pertinent question, but I was kind of curious about the if arg less than greater than 2. Where did that come from?
Yeah, I thought I answered that because I saw you ask it in chat. That means not equal, so it's !equal.
Yeah, sorry.
That's okay. I don't know what I was doing the day I wrote this that made me use a less than greater than instead of !equal.
Yeah, I read it. I was just looking for it and I was like, yeah, they use it in BASIC. And I was like, I don't know, maybe it was nostalgic for BASIC.
I must have been, which is, I haven't used BASIC in a while. But that's the only language I can think of where that would make sense. So, yeah. Anyway, okay, so I changed it to !equal, thanks. Because that's a weird syntax. Alright, cool. Any other questions?
We're just not supposed to like use any of the standard library functions, right?
Like what?
Like importing string.h and like.
You can use string.h. I don't think you need it in here.
Yeah, well, for like 4.11, since I was having trouble, I didn't initialize my variable and was having trouble with the stack, and like I use string.length with extra, or with the string being passed in from main, and was able to get 2 more of the tests to pass, but not all of them.
Okay.
And like, and then I went back to the drawing board and tried a couple other ways before I figured out that I just didn't initialize.
Oh, okay.
But it kind of like was making me think like, oh man, I'm getting closer with these, but I couldn't get it to work just using my own logic.
Okay.
Yeah, so it just put it in my head, but it's not really that important otherwise.
So you can definitely use standard functions like string, things from string, or obviously standard I/O, and so on. But if we're coding up a sort, you don't want to use the quick sort function from the library, things like that. Let me take a quick peek though.
I guess we did do a math import before, didn't we?
We did a math because we were doing a square root function, and we definitely didn't want to write that ourselves. Although we could go back in time and sell it.
I think we already did that in 121.
Yeah.
Did you write a square root function?
Yeah, we had to do basically, I think it was a square root where we had to write the function ourselves.
Cool.
Yeah, it was
I think
the
that was our
Newton's
intro
method.
function thing. Yeah.
Oh, excellent. That's a great program assignment.
Yeah, it was fun.
Cool. Yeah, you can take a whole course where like a numerical methods course where you learn how to solve equations or calculate, roots or things like that through programming, and that's a lot of fun. So on the ODP, checking the string length of extra is not going to necessarily tell you whether something got loaded into there. And if you initialize extra, you can do that. But the easier way is to check the return value from sscanf. That's sort of the more clean way to do it, actually. See what sscanf returns, and if it's not 1, then you can just say, there wasn't an integer, or there was an integer plus some extra stuff, or there was nothing at all, but there was something wrong. But I can see how you use string length, and that looks like it would work better in this case, but yeah, maybe not perfectly in all cases. All right, along those lines, either raise your hand if you don't mind, or if you don't want to go public, send me a direct message if you are feeling like you're kind of iffy on programming assignment 2 right now, like you're not done, you haven't made a lot of progress, you're not 100% sure how to go, you're stuck at something. If you're having some kind of issue like that, send me a direct message right now, or raise your hand in the chat window or something to let me know. I want to get kind of a feel for where the class is on this assignment. This is not, obviously a judgment or anything like that. I'm just trying to get a feel for the class's status right now.
I will say it is funny that when you write this program in Bash, it is really different writing it in C.
Yeah, isn't
I had
it?
more trouble writing it in C for sure, but it was still a lot of fun.
Yeah, cool. Yeah, it's a very different feeling. All right, so looks like a lot of the class is still at a point where they need to do a chunk of work on this. So I'm going to try something tomorrow. I don't know if I'm going to do this going forward, but I'm going to do this tomorrow, and we'll see how it goes. I'm going to take tomorrow as an open lab day, which means the following. I will be here in Zoom at 11 o'clock till 11:50. I will not count attendance. Okay, you do not have to come to class tomorrow. But if you want to come and work on your code and ask questions or ask for clarification, or hop into a breakout room and show me your code and so on, I'm going to set aside tomorrow's class time for that. So kind of be like an extended office hours, but also in a group setting and not competing with students for advising time and stuff like that. And if you just want to come in and hang out and work on your code, you can do that. Or if it's like, I really don't understand that scanf business, can you go through some examples of that, right? We can do that. I can talk to the class. If you're willing to share your code, I can use that as a specific example and so on. So you can do it like an open lab. And like I say, if you don't want to come, if you don't think you need to do that or something, that's fine. You don't have to come to class. You don't have to tell me. There's no attendance for tomorrow. But if you're still working on PA2, you can come in and we can do more kind of one-on-one work or get more specific questions about PA2. Does that make sense?
Yes.
Okay, cool. So that's the plan for tomorrow. Um,
Could I actually just as like a baseline, how how many lines per year will write this program in? If you, they're not exact, but just roughly the state program. Because I noticed mine, you know, for like AP 411, I was like sitting at probably like 20 something lines of code. You did it in like 5.
Okay, let's see. Keeping in mind I probably don't have as many comments as I'd like to see. So 120 lines.
Alright, so that's about 50 less than mine.
I have a bad habit of cramming as much like logic into single conditional as I can.
Mm-hmm.
There's a lot of spacing between ifs and what they're actually gonna do.
Yeah.
Statements.
So
Just so
there's
that it's easier to read.
yeah, there's lots of different style choices one can make. Some people use more space between sections. Some people will put a big block of comments in front of each function. There's all kinds of things like that. As far as how the code is written, there's so many different ways to do, you know, any of these things. The ODP we just finished.
I like to keep all the like nested conditionals together. You know, keep it like if, else, if, you know, or else if. And
Yeah.
a couple spaces between that and the next one.
Right. So I could have said if return is not equal to 1, return -1, else, and then I could have had a new line over here. And I could say if I equals 1, return 1, else if I equals 2, return 2, else if I equals 3, return 3, else return -1. I mean, there's lots of ways to structure this logic, and they can all be perfectly correct, and you know, as efficient, and so on and so forth. You could use a switch statement, and you could switch on I. You could multiply return by 7 and add I times 3 and switch on that.
So you don't need the curly brackets if you're just doing a return value?
If you're just doing one statement after an if, you don't need curly brackets. But I wrote this apparently before I decided to tell students that they should always use curly brackets. Because it will save you down the road. The trick is, if I wanted to do one extra thing in this if statement, now I need curly brackets. And if I forget and I just add, you know, a print statement here, my code will ruin my day. So for example, if I wanted to do this, you know, like that, my code is going to cost me half a day of my life, because this is the only thing that goes with the if statement, and then this is an unconditional return. And if I put it on the next line, I would see that immediately. But if I had curly brackets around here and I put this inside the curly brackets, this would do exactly what I wanted it to do. So, but yeah, in reality, if you don't have more than one statement, you don't need the curly bracket.
Okay, that's cool.
So yeah, lots of ways you can do this, and again, you know, the way that makes most sense to you, that's the best way to do it. And program length is, you know, I mean, you can write most C programs on one line, because spacing doesn't really matter. New lines don't matter, right? So I mean, I could take this, and I could.
Well, it's as long as you have the terminators at the end of the lines, right?
Yeah. So I mean, this will compile and run, and that's a 2-line version. But you know, you don't want to do that. You don't want to have to work with that. You don't want to have your colleagues at work have to work with that. And
somebody getting homicidal over it.
Yeah, right.
Something like that, one of your functions.
Yeah, and you can get rid of a lot of those spaces too. Yeah.
Oh, yeah, I was thinking about that earlier.
Right.
Is yesterday's lecture for 224B, the video I seen was deleted?
Oh no, it should be on there. I uploaded it twice, and the first one got deleted. But it should be up there. If not, I will.
But I know I watched it, but then I just went back to that playlist later and just seen that it wasn't up.
Oh, you are right. I remember what happened now. I tweaked my my network connection while I was re-uploading, and it never finished. All right, I will upload that after class. That will be up. Sorry about that.
Does the number of lines we use, like if we're using extra spaces between our blocks of code, does that somehow like count against us in the efficiency of the code?
Nope.
Compile it or no?
Nope, the compile will take a little longer, but once it's compiled, all of those differences are completely gone, because you just have binary code. And you know, readability is super important. You want to write code that can be read easily, and if that means, you know, putting in spaces or you know, adjusting the line length so it looks like Snoopy's head or something, right? That's all good. Readability is in many ways more important than efficiency, certainly in a programming class. And other classes, you know, teachers will tell you other things. So some teachers will tell you that, you know, you can never repeat the same code twice in your program. If you're going to do something twice, it's got to go into a function. Well, that's a good general rule, but you know, if it's a single line of code, and it really makes sense having it right here, it might be clearer to not put it in a function, you know, or maybe you have to do some gymnastics to be able to pass things to a function. It might be clearer to write the same set of code 3 different places in your main program. So for us, we're interested in, you know, things that make sense to you and making sure that it doesn't, you know, look mysterious to you when you finish writing it, that you can look at it and understand what you wrote. And there's plenty of time later in other courses for people to be more kind of dogmatic about style and things like that. Let's see. So ODPs are one of the things you can't really use slip days on, because it's an automated grading. But you're going to have 20 or 30 ODPs throughout the course, hopefully, and the real purpose is not so much to, you know, determine your grade as it is to let you determine, you know, where you are. If we talk about doing this sscanf business and it didn't quite click, you'll know that when you do the ODPs. So they're worth more than 0 points, because honestly, if they were worth 0 points, a lot of people wouldn't do them, and it's important to do them. But there's no mechanism that that I have in place to go back and grade ODPs after the ODP has closed. But you know, if you miss an ODP, it's not a big deal, right? It's 1 out of a couple of dozen assignments, and the whole ODP percentage is relatively small. Let's see, for aliasing variants typos of git, would that interfere? No, that's a fine thing to do. So if you keep typing got instead of git, you could set up got to be an alias, and that's not a common thing. I don't know if you've had a chance to notice, but you know, I have a shortcut for $Linux that automatically logs me into the Linux server. But you know, a lot of times I accidentally leave my shift key on from the $, and I do this. So that's another alias for the same thing. So yeah, unless you know that there's a command like got or gut that you want to use, go ahead and set up your alias. And your aliases are local to your bash environment. They don't affect anybody else, and if you don't put them in bash RC, they actually go away when you log out. So yeah, set that up however works for you. I have a lot of lines because I like bells and whistles in this class setting where lines don't count against us, and I like taking advantage of that. Excellent, yeah. Definitely, you know, be creative. This is like painting, you know. If you want to make your trees purple, make your trees purple, long as your program works. For PA2, do you want the compiled binary? I will probably recompile your code myself. So if you give me a compiled binary, I'll probably just overwrite it. So I don't need that, but you don't have to delete it. because 11th hour you try to delete the binary, you accidentally delete the .c file and so on. So you can leave it in there. All right, so let me talk a little bit about top-down design, and we had more time for this in the previous section, so you can look at the section A video maybe if you want to see more detail on this. But let me introduce this topic. So we're playing with functions now, right? And we can do functions in Bash, but when we did our Bash assignment, we weren't really talking about functions. We kind of just wrote everything, for the most part, in just one big script with a lot of ifs and a lot of nesting and things like that. With a language like C, right, we have the option of pretty easily taking sections of code and moving them into a function. And when we want to execute those sections of code, we just call the function. And if the function is called, start, we just say start, paren, paren. And so one thing functions can do for us is they can take code that we seem to repeat, and we can write it once, put it in a function, and then just call it. And of course, a lot of the code we write depends on certain information to control what it does. Like when we print the pile of sticks, well, how many sticks is it going to print? It depends. Sometimes we want to print 5, sometimes we want to print 13. So a lot of times this common set of code needs information to know how it should act. And that's what the idea of passing arguments to a function is all about. So when I call my function, say start, I can say start parentheses and put some number in there, some value, and now my function can do something based on that. And then sometimes the results of these common sets of code is to calculate a value. And we'd like to have access to that value so we can return a value from a function. That's what the return statement does. So with that in mind, we can start to think about when we're working on a program like our stick game, we can start thinking about how could we break this into functions. And you don't need to do this for PA2, and if you're already mostly done with PA2, you don't need to go back and think about this, but kind of going forward, or if you're stuck on PA2, here's just some examples of how this might play out in our stick game. So we're playing the game of stick, and what do? We look at command line arguments, we ask the user how many sticks, we do some sscanfs, we do all this funny business, right? But all of this stuff in the beginning leads to one of two things. Either there was an error, goodbye, or we know how many sticks to play with. So my main program could do the following. It could say, let's do all of that setup inside a function. And if my main is argc, argv, this is pseudocode, this isn't compilable C code, right? I could pass these things to my setup function. And my setup function will look at this, it will see if argc is 2, and if it is, it will parse argv1, and it'll do the scanf business and all of that kind of stuff. And if argc is equal to 1, it will print a message, how many sticks do you want? And it will do an fgets, and it will run that string through sscanf, etc., etc., etc. All that stuff, that could be like 50 lines of code, right? But in the end, one of two things happen. Something went wrong, goodbye, or I know how many sticks to play with. So I could write one statement in my main program like this. Integer num equals setup. And then I could define that my setup function, if anything goes wrong, it's going to return, I don't know, -5. So if num equals -5, I'm just going to return. And there was some sort of error in the setup. Otherwise, if I get through here, guess what? Num is how many sticks I want to play with. So I'll say play with num sticks. Well, I could start writing my code, you know, take the number of sticks, mod 4 if it's equal to 0, set something equal to 1. Say you're taking that many sticks, subtract it from the pile of sticks. Now go through a loop and print out my pile of sticks. Now ask the user how many sticks they want to take, and so on and so forth. But in a real top-down mindset, right, what do I want to do after I've decided how many sticks to play with? I just want to play the game. I'm going to take all of that behavior, I'm going to put it in a separate function called play game. And play game, I'm just going to tell it how many sticks we're starting with. And that's going to do all of those complex things. Do the computer turn, do the user turn, ask how many sticks, print stick piles, and so on and so forth, until the game is over. And so I could define a return value from play game, and I could save that result in an integer called winner. And I'm going to say if the CPU wins, I'm going to return a 1. If the user wins, I'm going to return a 2. And so now I can say, you know, if winner equals 1, print I win. Else print you win. There's my whole main program. So this is top-down programming. The idea is that, you know, this is my entire stick game. It's a call to setup and a check to see if setup found an error, and if it didn't, it's a call to play game, which tells me who won, and then it's one of 2 print statements to say who won the game. That's my whole program, right? I scratched it out on paper in about 3 minutes. I could type it in about 3 minutes. And I didn't have to think really deeply about how to do these. I mean, there's an if statement, there's an if else, and there's a pair of function calls. So writing this is not terribly hard, but of course the detail is that I still need to write this setup function, and I need to write this play game function, and those are very complex. But not as complex as writing the entire PA2 program. Because setup, well, that's going to look a lot like some ODPs you've done or are about to do. And this doesn't do anything with, you know, mod 4 and getting user choices for number of sticks and printing stick piles and so on. This is a simpler task than PA2. And play game is simpler than PA2 because we don't have to worry about parsing how many sticks you want and looking at argc and argv and all that kind of stuff and looping and so on and so forth, right? This is just a function, we tell it how many sticks to play with. So top down, we're basically starting with the top level view of our program, our main program, and we're punting to yeah, so it's like a tentative outline for an essay, exactly. So I'm going to have, you know, an introduction, and then a basic argument, and then some supporting evidence, and then conclusions, right? And you know, once you type the headers for those, it's like, hey, you know, I got my paper done. I just have to fill in the details. Well, that's what we're doing here. So now, you know, you're working with the ODPs, you're thinking about argc, argv, you start working on your setup function, you know. Or you want to play the game, you start working on your play game function. And what does play game look like? Where num's the number of sticks. Well, CPU is going to take a turn, right? We're going to tell this function CPU turn how many sticks we have. And I'm going to define CPU turn to return the number of sticks after the CPU's taken a turn. So CPU turn num, and I can say if num is less than or equal to 0, well, that means the computer won, so I'm going to return a 1. Otherwise, I'm going to take a user turn, tell it how many sticks we have, and I'll write this user turn function to return the number of sticks left afterwards. And I'll check that, and if num is less than or equal to 0, that means the user won, so I'll return a 2. And then I'm just going to put all of this inside a while forever loop, while 1 equals 1. Well, there's my whole play game function. That only took a minute to write. But you know, now I've given myself 2 more tasks. I have to create a play turn, a CPU turn, and I have to create a user turn function. But this is easier than this, and this is easier than this. This is just the CPU's turn. This is just the user's turn. So we're breaking our problem down into smaller and smaller blocks. That's the essence of programming. That's what you are as a programmer. You're a problem solver who solves problems in large part by breaking them into smaller problems. And you break these down until they get into such small pieces that you write a few lines of code and you've got your solution. Or if you're in a team, you know, you hand it off to somebody and they write this and somebody else writes that and you put them together. So we'll talk about this a lot throughout the course and throughout the year, actually. But it's just something to keep in mind. Like I say, if you haven't already done this, don't worry about it, right? Don't rip up PA2 and go back to the drawing board. But if you're kind of stuck on how should I be proceeding, this seems like a big complex problem, how do I approach it? This is one approach, right? Start breaking it down into pieces. This is a lot of planning and writing things out on paper before you actually start writing code. All right, we're past time. Send me a final attendance note, and we'll leave this for now. We'll talk more about this tomorrow. We'll talk about car star star tomorrow, and I'll see you then. Is there a limit on how many functions, scrolled off the top of the screen, can be used? Not really. I mean, you could have 10,000 functions, and the compiler wouldn't even blink. So that's not a problem.
Did I miss the first attendance game?
I don't know.
So,
I think I took one in the beginning, but you're here now, so you're good.
okay. Thanks.
All right, and tomorrow is a lab day, so if you're not coming into lab, I won't see you tomorrow. But I'll see you in 2:15 if you're in 2:15 in a half hour. All right, thanks. Have a good one.